So just to illustrate this example, imagine we start off with some graph H. It's a little bit of a mess. There's lots of edges in here. What we're going to do is convert this to a new graph G, which is the complement of H. And so every place in H where there is an edge, we leave the edge out. And every place where there's not an edge, we add an edge. So for example, this node is not connected to this one or this one. So in the complement graph, we connect it to that one and that one. This node is connected to 3 on the top and 1 on the bottom. So we connect it to this one on the top and these 2 on the bottom. This one on the top and these 2 on the bottom. Right. So we've carefully constructed this complement graph G. And the thing that you need to realize now is that G, this new graph, which is the complement of H, has an S-clique if and only if H has an S-independent set. In fact, it's the same set of nodes. So here's our 4-clique, for example. This is similar to the graph that we looked at before. This is our 4-clique in G. And if we look, that corresponds exactly to a 4-independent set in H, right? Because if it has all the pairwise edges in G, then it has to fail to have all those pairwise edges in H. So that's how we can use a solution to the clique problem to solve the independent set problem. Now in this particular example, well, it illustrates a general idea, which is we take instances of one problem and we transform them into instances of another. In this case, the transformation is really very straightforward. Maybe it wasn't obvious to you at first. Now that I pointed out, it's probably pretty straightforward. Some of these reductions actually can be much more involved. This one actually is also really easily reversed, right? So if we have an algorithm for independent set, we could use that to solve the clique problem the same way. Invert the graph, right? Complement the graph, look for the independent set, and that tells us what the clique is in the original graph. But sometimes, again, the connection is not always so straightforward.